Everyone, in this video, I'm going to explain the MLT experiment number 5, multi-layer perceptron using PyTorch. In this experiment, I built a multi-layer perceptron model using PyTorch to classify handwritten digits from the cyclic dataset. The dataset contains images of digits from 0 to 9, and the goal is to correctly predict the digits. First one, importing required libraries. First, I imported all necessary libraries. PyTorch for building and training the neural network. NumPy and Matplotlib for data handling and visualization. Scikit-learn for dataset preprocessing and evaluation. And the second one, loading the dataset. I used the digits dataset from sklearn. It contains 1797 samples. Each image is 8 cross 8 pixels, flattened into 64 features. X is the independent variables pixel values. Y is the dependent variables, digit labels 0 to 9. And the third one, data standardization. I standardized the input features using standard schema. All features have mean is equal to 0 and variance is equal to 1. Helps a neural network learn faster and more efficient. And the fourth one, train test split. I split the data set into 80% training data, 20% testing data. Train test split test size is equal to 0.2. Training data is used to learn. Testing data is used to be evaluate performance. And the fifth one, convert to PyTorch tensors. Since PyTorch works with tensors, I converted the data. X train T is equal to torch.float tensor X train. Y train T is equal to torch.long tensor Y train. Inputs float tensor, labels long tensors required for classification. And the sixth one is building the MLT model. I created a deep neural network with multiple layers. Architecture follows input layer 64 neurons, hidden layers 128, 64, 32, and 16. Output layer 10 neurons for digits 0 to 9. Activation function used RELE with 5 linear input. Introduces non-linearity. Final layer output 10 values for classification. And the seventh one is loss function and optimizer. Loss function, cross entropy loss. Optimizer, stochastic gradient descent, SGD. Criterion is equal to n dot cross entropy loss. Optimizer is equal to optim CD. Model dot parameters, LR is equal to 0.01. This help measure the update model gains. And the eighth one is training the model. I trained the model for 500 images. Process inputs forward pass, compute predictions, calculate loss, backward pass, compute gradients, update weights using optimizer. Loss or backward optimizer step. I also stored loss values to track leading. And the ninth one is plotting training curve. I plotted images with loss. This shows how the model improves over time, whether it is learning properly. And ninth one is testing the model. After training, I switched to evaluation model.evaluation. This predicts outputs for tested data, selected class with highest probability. And the tenth one is model evaluation. I evaluated performance using confusion matrix. shows correct versus incorrect predictions. Metrics include accuracy, overall correctness, precision, correctness of positive predictions, recall ability to form all correctnesses, F1 score balance between precision and recall. And then finally, in this experiment, I successfully built a neural network classifier, trained it on handwritten digit data, evaluated it using multiple performance metrics. The model learns to recognize digits automatically using deep learning. And finally, this experiment demonstrates how a multi-layer perceptron can be used for image classification and how pre-processing, training, and evaluation all work together to build an effective machine learning model. Thank you.